Hello students, welcome to Darasa Online. My name is Naftal Lucas Makumbire, a chemistry teacher. Today I want to review with you Form 4 students. And as you can see, the topic is organic chemistry. And the subtopics are here, hydrocarbons and the properties of hydrocarbons. So today I'm going to review with you these two subtopics. They are very, very important because if you meet with most of the students, they have the problem with organic chemistry. And they think organic chemistry is a difficult one. And some are running, they don't want to study it. If you ask them the question why, they say that it is a difficult one. But also, even those who have studied it, they have the knowledge. But answering the questions coming from these particular parts, it has become the problem. That's why this topic is chosen for you so that we can view together. And I'm sure that today you're going to be very confident and also competent in solving different questions relating to these two particular subtopics. So by the end of this lesson, I'm sure that you are going to investigate the properties of organic compounds and their applications in our daily life. Therefore, I would like to take this opportunity to welcome you to connect with me from now till the end of this lesson. Now, you are warmly welcome. So as the subtopics are written here, hydrocarbons and the properties of hydrocarbons. The first thing that we have to know is to define or to understand what is it all about hydrocarbon. That is very, very important. If I ask you the question, what are hydrocarbons? What are you going to say? It's very simple for you to understand this. Now let's start with that one. What are hydrocarbons? That is the first thing. Now, when we talk about hydrocarbons, as you can see here, hydro and the carbons. So here, hydro from hydrogen, and this is carbon. Therefore, these are organic compounds which are made up of carbon and hydrogen only. Simple like that. Can you forget it? I'm sure that you can't. So these are organic compounds. Yes, these are organic compounds which are made up of carbon and hydrogen only. So this is all about hydrocarbon. Now, after we have discussed the meaning of hydrocarbons, hydrocarbons is divided into two main groups. The first one, these are saturated hydrocarbons, and the second one is unsaturated hydrocarbons. So these are the two main groups of hydrocarbons, saturated and unsaturated. What are those? What are saturated hydrocarbons? What are unsaturated hydrocarbons? It is important for us to know the meaning of each and even giving the examples. Now let's start with saturated hydrocarbons. When we talk about saturated hydrocarbons, here we are referring to those hydrocarbons with the carbon-carbon single bonds. That means the carbon atoms have maximum number of hydrogen atoms per carbon. That is very simple. So when you talk about the maximum number of hydrogen atoms per carbon, it means the valence of carbon is very, very important for you to understand. Do you remember that the valence of carbon is 4? Yes. So saturated hydrocarbons here are referring to alkanes because they have single carbon-carbon bond. These are hydrocarbon with a single carbon-carbon bond. Examples of these ones: alkanes. Yes. Now if we come to give the functional group of alkanes, it is a single bond between carbon and carbon, like this way. So you can see this one, single bond between carbon and carbon. So that means, you see this carbon is bonded to 3 hydrogen atoms because of the valence, one of the valence of it has been used to bond with the carbon. So remaining valence are 3, so 3 hydrogen atoms are here. This as well. So when we have examples of these ones, look at this example. This one. Can you see that example? There is single carbon-carbon bond. And the first carbon is having how many hydrogen atoms? 3. That is the maximum number of hydrogen atoms for this carbon, because it has used one valence to bond with this carbon. But the second carbon, this one, the middle one, he's having the maximum number of 2 hydrogen atoms. Why? Because this carbon is bonded to 2 other carbon atoms. The first valence has been used to bond with this one, and the second to bond with this one. So remaining valence is 2. That's why it has got 2 hydrogen atoms. So it is simple to explain in that way. So saturated hydrocarbons, they have single carbon-carbon bond. Now, after we have discussed about that one, hydrocarbon with a single carbon-carbon bond, let's go to the second one. The second one is unsaturated hydrocarbons. What are these? These are hydrocarbons with carbon-carbon multiple bonds. Yes. When we talk about multiple bond, what comes in your mind here? Here, multiple bonds. Multiple bonds here refers to 2 bonds that we are talking. Number 1, double bond. Number 2, triple bond. Yes. Now, which hydrocarbons have the double bond? These are alkenes. Alkenes, they have carbon-carbon double bond. And which hydrocarbons have triple bond? These are alkynes. They have carbon-carbon triple bond. So giving examples, the functional group of alkene, this one to right is written this way. Can you see this one? The double bond is present between these 2 carbon here. So as you can see, this is the way the functional group it is written. When you are taught to write the functional group, do not put the hydrogen atoms. You write it in that way. It is very simple. For example, if we have this one, you can see this carbon this carbon, there is a double bond between carbon and carbon, this one, as you can see. So it is different as you compare to this one. The middle carbon has 2 hydrogen atoms. How about this one? It has got only 1. Why? Because of the presence of the double bond. The double bond reduces the number of hydrogen atoms per carbon. So that's why it is called unsaturated. That means it still needs more hydrogen atoms. It can be added here to make to complete the valence of carbon atoms if one of the bond will be broken down to allow the molecule to be added. So it is simple like that. Now for the case of alkynes, for the case of alkynes, they are written this way. This way. There is a triple bond between 2 carbon atoms. Now, to give an example here is like this way. Sorry, let me write it properly. I'm sure that you can see here. The carbons with the triple bonds, they are different from this one, as you can see. You can see this carbon here has got no hydrogen atoms. Why? Because of the presence of the triple bond. It has consumed all the valence of carbon atoms. Remember, the valence of carbon atom is 4. So this carbon is bonded to this one. One valence has been used. And these 3, they make it 4. So this one has got no hydrogen atoms. So this is very saturated as compared to alkene. So it is very simple to represent in that way. After we have seen what is all about this one, we are going to pass through each one after another. So there is no need of worrying. Now let us see the family of hydrocarbons. Families of hydrocarbons. There are 3 families of hydrocarbons. Number 1, we have alkane. Number 2, we have alkenes. And number 3, we have alkynes. As we have discussed them here, so there is no problem with them. There is no problem. Now, after we have seen this one, it is our focus today will be about this one, alkane. We are going to discuss the rest in the coming presentation, so there is no need of worrying. So specifically today, we are going to focus on alkane, the first hydrocarbon. So, if I ask you now, what are alkanes? Can you be able to tell? It is a simple one. We have discussed about saturated and unsaturated hydrocarbons, so you can be able to tell this one. So, yes, these are saturated hydrocarbons with carbon-carbon single bond, alkanes, simple like that. Now, the presence of the single bond in alkenes make this one to be unreactive. So when you compare the reactivity of alkanes with the rest, this one is the unreactive, is the most unreactive as compared to this one because of the presence of the strong single bond which is present between carbon and carbon. So a large amount of energy is needed to break them. That's why they react slowly. So alkanes, they have the general formula of them. It is important to see. General formula of this one is this way. This is the general formula of alkanes. N represent number of carbon atoms. Represent the number of carbon atoms that an alkane is constituting. Now, after we have seen this one, it is important also to remember the formula, the types of formula that we are going to consider in our discussion. In Form 2, in the topic of formula, bonding, and nomenclature, you learned about the types of formula, empirical formula and the molecular formula. I'm sure that you remember them. So in this level, I'm going to introduce to you another type of formula, and this is a structural formula. So it is important to understand this one because we'll be passing through it several times. When you talk about a structural formula, we are talking about the formula which shows the arrangement of atoms in a molecule. Yes, it's the formula which shows the arrangement of atoms in a molecule. How atoms are arranged in a molecules. It is very simple. And here we have the types. Number one, we have the condensed structural formula. This is also called closed structural formula. This one shows the atoms only. It shows the atom only. But the second one, we have the open structural formula. This one shows the bond. It is important. We are going to see this one in a few minutes to come, so there is no need of worrying about this one. Now, after we have discussed about this one, let us see the homologous series. Homologous series of alkanes. What are homologous series? I'm sure that you remember it. Homologous series is the list of organic compound in which one member differs from the next by a constant group, and this is CH2 group. Now, according to your level, we are going to study the alkanes up to 5 carbon atoms only. That is what we're going to study. So, the first member of alkane is methane. Homologous series of alkanes. Now, when we talk about homologous series, we are talking about the members of alkane. There are several members of alkane, but according to your level, we are going only to study the members of alkane up to 5 carbon atoms only. So, starting with the first member with 1 carbon atom, this is methane. This meth means 1. Therefore, methane is an alkane with 1 carbon atom. How can you know that it is an alkane? Because of ane. This ane represents it is an alkane. That means it has got a single carbon-carbon bond. How do you know that is 1 carbon atom? Because of meth. Therefore, here N is equal to 1. Do you still remember the general formula of alkanes? It is here. Cn H2n plus 2. So if you put here N to get the molecular formula of methane, it is very simple. You can put it here. NC, it will be 1. N is 1 times 2 is 2. Plus 2 is 4. So here is 4. So there is no need of writing 1 here. So the molecular formula of methane is that one. So you can see, the first member has got 2 carbon atoms. Ethane, 2 carbon atoms. That means N is equal to 2. How do you know that N is equal to 2? There is no need of worrying. This F means 2. And how do you know that it is an alkane? Because of ane. The suffix of ane. That means all alkane end up with ane. So this is an alkane with the 2 carbon atoms. Therefore, if you substitute these 2 here, what are you going to get? The molecular form of this one. It will be C. Here it will be 2. And 2 times 2 is equal to 4. Plus that one is equal to 6. So we have 6 hydrogen atoms. Can you see the difference? The difference here in carbon, 1 carbon atoms, hydrogen, 2 hydrogen atoms. And that is homologous series. Let's go to the third one. The third one, we have propane. Propane, which is N is equal to 3. Prop means 3. Ane means alkane. Therefore, this is an alkane with 3 carbon atoms. Substitute this N up to here, to this formula. What are you going to get? C, it will be equal to that one. And 3 times 2 is equal to 6 plus 2 is equal to 8. So we have that one. So can you see the difference? The difference here, 1 carbon atom, the difference 2 hydrogen atom. Number 4, we have butane. But means 4. Ane, it is an alkane. Therefore, this is an alkane with 4 carbon atoms. Therefore, N is equal to 4. Substitute here. We get C, 4. 4 times 2 is equal to 8. Plus 2 is equal to 10. So H is 10. As you can see, the difference continues to be, there is a constant group there, CH2. That is what makes a difference. The last one is pentane. Pent means 5. So if you substitute there, we are going to have this formula. H, 5 times 2 is equal to 10, plus 2 is equal to 12, as you can see. So this is your level. So what makes a difference here? There is a constant group, that is CH2 group. And that is the meaning of homologous series. How can you represent them in a structural formula? Let us see how can you represent them in a structural formula. Now we have this one. Let me use this all space so that we can have a good looking. Here we have alkanes. Here we have molecular formula. Here we have open structural formula. Open structural formula. Yes, so we have alkane, we have molecular formula, open structural formula, condensed structural formula. Starting with the first one. The first one, methane. Molecular formula we have described a few minutes ago. So it is CH4. You can use the general molecular formula as I have said. CN plus 2. You get this one. 1 carbon atom, this one, 2 times 1 plus that one, you get 4. Open structure, it has got only 1 carbon atom. In open structure, we show the bonds in that way. We show the bond between carbon and its hydrogen atoms. Condensed structure, we show the atoms only in that way. So it is very simple for you to do it. Let's go to the second one. The second one is ethane. Ethane, we have described the molecular form of it, C2H6, by putting here. Eth means 2, so it is 2. 2 times 2, 4, plus 2 is equal to 6. How to write the open structure? We have 2 carbon atoms, so you write 1, 2. 2 carbon atoms. Remember, alkanes have single carbon-carbon bond, so there is no need of worrying. So you fill the hydrogen atoms depending on the valence. This carbon has used 1 of the valence, so remaining how many? 3. So you put it in this way, and this is the meaning of open structural formula. You show the bonds. This as well as used 1 valence, remaining 3. You put it that way. So you can see we have 2 carbon atoms and 6 hydrogen atoms. 1, 2, 3, 4, 5, 6, as it appears here. Condensed one, you show the atoms only. This carbon atoms has got how many hydrogen atoms? 1, 2, 3. So you write them this way. And how about this one? 1, 2, 3. So you write them this way. Can you do the rest? Now, finish this one. Finish propane, Finish this one for yourself. Finish also butane. And lastly, pentane. So take your time to finish with this one, as methane, ethane, propane, butane, pentane. So finish the three. Use the same principle to have those ones. So it is very simple after we have discussed that one. I'm sure that you are following. Now, after we have discussed this one, let's go to nomenclature. How can you name these compounds? Yes, nomenclature. Nomenclature, this is the system of naming, simple like that. So because we are talking about alkanes, nomenclature of alkanes means the system of naming of alkanes. This system is very organized. We have this International Union of Pure and Applied Chemistry. This one. This union, International Union of Pure and Applied Chemistry, has given us the system on how to name different organic compounds. And specifically, because we're talking about alkanes, how to name alkanes. I'm going to analyze some few rules generally to consider when you are naming alkanes. They are very simple. Number one, select the longest continuous chain. This is called parent chain. Select the longest continuous chain, and this is called the parent chain. It is very simple for you to do that. That means the chain with larger number of carbon atoms should be considered to be the parent chain. After you have identified that one, then you come to another one, numbering of carbon atoms. So numbering of carbon atoms should start at the end closer to the substituent. Now what is the substituent? That is also very important. Let us see a substituent. What is it all about? Substituent. This Yes, this is an atom or group of atoms bonded to the longest continuous carbon chain, bonded to the longest continuous carbon chain. And the most common of substituents are alkyl. The most common substituents are alkyl groups. Another question arises, what are alkyl groups, so that you can understand clearly what is a substituent means. Alkyl groups, these are alkanes. These are alkanes with one less hydrogen atom. That is the meaning of alkyl group. So they are obtained from alkane. That means the general formula of this one yes. CnH2n plus 1. Here there is no 2. For the case of alkane, there is 2. This means one hydrogen atom is less. So this is the formula of alkali groups. Let's see the examples of them before we proceed to nomenclature, because it is very, very important for you to understand them. Number 1, if we have methane, for example, this is alkane. The formula of it is CH4. Now, when one hydrogen atom when one hydrogen atom here is not here, that means you're going to have this one, this way. So this is called methyl group. The suffix of this one is allyl group. That means you end up with allyl group. So it is important for you to remember that one. So when you are naming this alkyl group, you end up with allyl group. So you remove ane, you put allyl group. It is like that one. This shows that this carbon is bonded. Ethane, which is C2H6. This is the molecular form of ethane. But when one hydrogen atom is less, for example this one, C2H5, this is called ethyl group. So you can proceed, propyl group, butyl group, etc., etc. So after we have seen that one, if this group are present on the chain, that means you start from the end closer to this substantive group. And of course, the side which is closer would be the lowest possible number, as we are going to see later. After that one, the third one, identify the position of the substituent. After you number, here, what are you going to do? You identify the position. You have numbered, yes. You identify the position and the substances which are present. Therefore, after you identify them, it becomes easy now for you to name different compounds. So it is very, very simple. Now, if the substances are present more than one, but of the same, you can use the prefixes like di, this means 2, tri, this means 3, tetra, this means 4. For example, if there are 2 methyl groups bonded to the longest continuous chain, we say dimethyl, dimethyl. If there are 3 trimethyl of the same, so use these prefixes. They're very simple. Now let's see the examples to see how the questions also are coming from this particular part. Now let's go to see the questions. Now here we have the questions. Question number 1, give the IUPAC name for each of the following. Give the International Union of Pure and Applied Chemistry name for each of the following organic compounds. The first one, this one, CH3, CH2, CH bracket, CH3, then CH, there is a chlorine atom here, then CH3. What is the meaning of this bracket? Sometimes expect to get these kind of questions, because sometimes you are given direct that there is a branch here, but this bracket means this methyl group is bonded here. So let's see how we can go through that questions on the board together. Now, question number 1, Roman 1, we have CH3, CH2, CH bracket, CH3, CH, that one, CH3. That is what we are given. CH3, CH2, CH, there is a bracket, CH3, then CH, chlorine atom is here, CH3. This one can be written also in the same way as this one. CH3, CH2, then CH, this is a substituent group. That's one. The bracket means this methyl group is bonded to this carbon. We have CH. This also is bonded to this carbon. And then we have CH3. That is the way. Now, how do we select the longest continuous chain? You consider only the number of carbon atoms. 1, 2, 3, 4, 5. Automatically, 1, 2, 3, 4. So this is the longest chain. It contains how many carbon atoms? 5. 1, 2, 3, 4, 5. So the longest chain, the parent chain is pentane because it consists of 5 carbon atoms. Now, which side will be? Will you start counting? If you start this way, 1, 2, to the second carbon, you're going to meet with this group here, and to the third one, you're going to start with this here. So if you count from here, 1, 2, to the second carbon, you're going to give, we are going to get the chloride group here, and also to the third carbon, you're going to methyl group. Now this is called locant. Now if you take this one, the second carbon, you just sum. You take this carbon, the first one, the second, if you start this way, the third one, the fourth one, the fifth one. If you start this way, that means the second carbon contains this group, and we have the third carbon contains this group. So you have the carbon number 2 and the carbon number 3. You plus you get 5. That is the number that we get. But coming here, if we take this side to be the first, 1, 2, 3, 4, 5. So here 1, 2, 3, 4, 5. That means the third carbon, you're going to meet with a substituent group. This is number 3 plus. The fourth carbon, you're going to meet another substituent group. This is 4. So you can see 4. 1, 2, 3, 4. So when you plus, you're going to get a 7. So which side will you start counting? The side which will be the smallest number is the side that you're going to start with. So this side, which gives 5 number, 5 is smallest than 7. So this side will start. So numbering of carbon atoms will start this one. Number 1, number 2, number 3, number 4, number 5. So it is very simple. After you have defined that one, you follow the alphabetical order in naming the substituent now. This is C, this chloride group here, and this is methyl group. So C and M, which one starts? C. So in which carbon? 2. So you put that number, the position of this group here, carbon number 2. Then you put an hyphen there because there is only one. You say this group, it is called chloro. You finish that one. To separate that one from another, you put an hyphen there. You go to the third carbon, only one methyl group, so you put an hyphen there. You say that group, methyl. All the substituent groups are over. Therefore, you name the parent chain. Contains how many carbon atoms? 5. So you say it is pentane. Simple like that one. So this is the name of it. That is number 1. Now, when you go to here, let's do also this part, and we are going to do the rest. So it is very simple. Let's come on the board to see how we can do that one. Now, Roman 2. Roman 2, we have CH3, CH. That branch means there is, sorry, that bracket means that methyl group is bonded to this carbon atom. Then we have C. There is bracket here and a 2. That means there are 2 methyl group bonded to this carbon atom. And to finish, we have CH3. That is the one, CH3. CH, there is methyl group. C, we have 2 methyl group and CH3. It is very simple to name that one. You can see even this side, 1, 2, 1, 2. Which side bears the lowest number? Now, when you come to this carb, 1, 2, 3, 4. Or in a very simple rule, as you can see, there are 2 methyl group. This one is more branched, so you start here. Number 1, number 2, number 3, number 4. It's very simple like that one. So we have 3 methyl group, which are substituents to the second carbon and to the third carbon. So you give the location of them, or the position to the carbon that they are bonded. So you come 2. The second carbon, there are 2 methyl group. You put comma 2. Don't put an hyphen here. You're finished with that carbon, you go to the third one, because in the third also there is methyl group. After you have identified them all, then you put an hyphen. How many are there? There are 3. So trimethyl. Then you finish with the parent chain, which contains how many carbon atoms? 4. So this is butane. So you see 2,2, 3 trimethyl butane. It is very simple like that way. So you can do this one by yourself. There is no problem. Now let's, after we have discussed about that one, let's go to another question. So let's go to question number 2 to see also how the questions are coming. Let's go to this question. The following International Union of Applied Chemistry name are incorrect. Write the structural formula of the compounds and its correct name. That is another way you can meet with that questions. That is very simple. For example, Roman 1, 2, and a hyphen, methyl, and a hyphen, 3, bromobutane. I'm going to do this one and you're going to do the rest. It is very simple. Let us see how do you do that one on the board together. Now, coming on the board, question number 2, Roman 1. You are told to write the formula, the formula of the given name, and you give the correct name. Here, you are given 2-methyl, and the 2-methyl and 3 bromo-butane. So butane is our parent chain. How many carbon atoms? 4. So you write this 1, 2, 3, 4. After you do that one, then you can start from either side. If you start this one, no problem. If you start this side, no problem. You allocate the given substitute groups. So here, if you start this one, 1, 2. In the second carbon, we are told there is methyl group. So you put it there. You go to the third carbon, with that group there. So there is no problem. After there, you fill the valence of carbon. This one is used 1 valence, it needs 3 hydrogen atoms. This one is used 1, 2, 3, it needs only 1 hydrogen atom. This one is used 1, 2, 3, it needs only 1 hydrogen atom to make the valence of 4. This one is used 1 valence, so here it is going to be 3. So this is the structural formula of that one. So you give the name, the correct name. Correct name. Correct name. The parent chain is butane. Where do you start counting? 1, 2, 1, 2, 1, 2. You can start from either side, but there is one limitation. If the two sides are equal, what do? You follow the alphabetical order. So this side will be considered because this group here, B, a bromide group, is alphabetically the first as compared to methyl group. So start this side. 1, 2, 3, 4. So thereafter, because this will start, then you give the position of it. The second carbon, it is only 1. You give an hyphen. You give the name of it, bromo. You put an hyphen to separate it from another group. In the third carbon, then it is an hyphen, methyl. Then all substances are over. You give the name of the parent chain. That is butane. This is the correct name. So you can see. So you're going to do the rest of this particular part. It is very simple. Now, after we have seen that one, let us proceed to see the isomerism. Isomerism in alkanes. Isomerism in alkanes. I can ask you the question, what is isomerism? It is very simple. Isomerism is the occurrence of organic compound with the same molecular formula but different structural formula. That is the meaning of isomerism. Isomerism. Now, the compound with the same molecular formula but different structural formula, these are called isomers. Yes, these are compounds with the same molecular formula but different structural formula. Now, in order to understand this one, let's go to write the isomers in alkanes. But the ways of obtaining isomers. In alkane, there is only one way. You can shift the carbon atom, take the carbon atom, and its hydrogen atom, you make it as a substituent. Yes, take carbon atom and its hydrogen atom and make it as a substituent. Let's see some examples. The first member of alkane, that is methane, has got no isomer, ethane has got no isomer, and propane has got no isomer. So the isomer are starting from butane. Let's see the question. Now let's go to the question. Suggest all possible isomers of the following organic compounds, butane and pentane. I'm going to read you on butane, then you're going to do it for pentane. It is very simple for you to do it. Now let's come on the body to see how we can write the isomer of that one. Now Romani 1, butane. When you want to write the isomers of butane, the first thing that you have to do, make sure that you write the molecular formula of it using this general formula that we have discussed it together for alkane. Therefore, the molecular formula, but we have said that means 4. So N here is equal to 4. So when you put here, it will be C4 hydrogen. 4 times 2 is equal to 8. Plus 2 is equal to 10. So we are going to get 10. So that is the molecular formula. Now, after we get that one, we write the isomers now. Isomer number 1. How many carbon atoms do you have? We have 4 carbon atoms. Therefore, 1, 2, 3, 4. It is very simple because this is single, carbon is single bond. Therefore, we put the number of hydrogen atoms balancing the valence of carbon. So number of hydrogen atoms here is 3 because this carbon has used 1 valence, so remain 3. This carbon has used how many valence? 2. So we put 2 hydrogen atoms. So we can put it generally in this way. CH3. This one has used how many valence? 1, 2. Remain how much? How many? 2 hydrogen atoms. And this one has used 1 valence. Remaining how many? 3. So this is CH3, CH2, CH2, CH3. Coming to the molecular formula, how many carbon? 1, 2, 3, 4 as they appear here. Hydrogen atoms, 3, 5, 7, 10. That is isomer number 1. And you name it. The name of it is butane. It is important to name because when you name, it will enable you to differentiate the isomers. Now we come to isomer number 2. Isomer number 2, we may take this one and make it as a substitute to come and bond it here. Now, when we make that one as a substitute, we can make it in this way. So in the chain, you're going to remain with 3 carbon atoms. 1, 2, 3. So this one, we make it as a substitute this way. We fill the valence of carbon by filling the number of hydrogen atoms. So here, we are going to have 3 hydrogen atoms. Here, this carbon has used how many valence? 1, 2, 3. Remaining 1 hydrogen atom. This one has used 1. Remaining how much? How many hydrogen atoms? 3. So you count the number of carbon. 1, 2, 3, 4. Just like they appear there. Hydrogen atoms, 3 plus 3, 6. Plus this one, 7. Plus 3, 10 as they appear. You name it. Naming it 1, 2. In the second carbon, there is methyl group. So the name of it is 2-methyl. Then the parent chain has got 3 carbon atoms. It is propane. It is propane. So it is very simple in that way. Now you can finish with the pentane. It is very simple. Now let's go to question number 4. Question number 4. Question number 4 says, What are the classes of hydrocarbons? Basing on the following, briefly explain. We have family, we have saturation. This is very simple. We have discussed about families of hydrocarbon, alkane, alkenes, and alkynes. Do you remember them? Saturation. We have discussed about saturated hydrocarbons and unsaturated hydrocarbons. So it is very simple for you to mention it. Now B, complete and balance the following organic reactions. Now, complete the following. 1, CH3, CH3, oxygen gas. And here we have CH3, CH3, chlorine molecule, the presence of sunlight. So this one, we can do it on the board as follows. Now, question number 4B, Roman 1. We have CH3, we have CH3, oxygen gas. Now what are we going to get? When alkane is burnt in oxygen, the products are carbon dioxide and water. So all, when we talk about methane, ethane, propane, butane, pentane, when they are burnt in oxygen, we get carbon dioxide and water. This is the combustion reaction. So here we get carbon dioxide and we get water. So you balance the equation. Balancing the equation, how many carbon atoms? 1, 2. Here we have 1, so we put it there 2. How about hydrogen atoms? 3 plus 3, 6. But here we have 2, so we put it there to have 6 hydrogen atoms. How about oxygen? Here is 4, 7. Here we have only 2, so we put this way, 7 over 2, because 7 cannot be divided by 2. So we put in that way, this and this will cancel. Therefore, 2 carbon atoms as it appear here, 6 hydrogen atoms as it appear here, and 7 oxygen atoms as it appears here. So it is very simple in that way. Now, the second part of the question is about CH3 plus chlorine. Reacting with chlorine molecule in the presence of sunlight. This one. Now here we get a reaction which is called substitution reaction. What is a substitution reaction? A substitution reaction is the reaction Yes, is the reaction in which one atom or group of one atom replaces another atom or group of an atom in a compound. So one atom replaces another atom or group of atom in a compound. That is substitution reaction. So what is, why sunlight? Because a single bond between carbon and carbon is very strong. It can't break easily. So therefore, alkane need a large amount of heat for them to be reactive. Therefore, chlorine molecule will break and to produce chlorine atoms. So one of the chlorine atom will replace one of the hydrogen from here. And the remaining, that hydrogen atom which is replaced will combine with one of the chlorine atoms here to make hydrogen chloride. So here we are going to have CH3, CH, remaining 2 hydrogen atoms, that one. And the chlorine atom has replaced one of the hydrogen atoms, so it gets there, and hydrogen chloride. It is simple like that one, as you can see on the board. Now here also we can have another one which is very, very important. Yes, which is very important. Now assume we have this one. This reaction. Here we have 4 molecules of chlorine. What will happen here? This reaction can take place into several steps. Number 1, The step is to replace one hydrogen atoms after another from this compound here. So starting with the first one, methane reacting with the first molecule in the presence of sunlight, this one, we are going to get this one. So one of the chlorine atom will replace one of the hydrogen atoms here and get into it, and the remaining chlorine atom will combine with the hydrogen atom that has been replaced to make hydrogen chloride, as you can see. The process continues because there are 4 molecules here. Now let's do it here. Romani 2, CH3, this one will react with another molecule of chlorine from here in the presence of sunlight. What will be the product? Hydrogen atom will be replaced here by chlorine. So we are going to remain with 2 hydrogen atom, and the chlorine atom will be 2 and hydrogen chloride in that way. So you can see the process continues till when all hydrogen atoms will be replaced. Number 3. Sunlight. This hydrogen atom, one of them will be replaced by a chlorine atom from here. So chlorine will be 3, we'll get here. Can you see that one? It is very simple in that way. Now to finish with this one, that one, the last hydrogen atoms will be replaced, and the product is going to be this one. So as you can see, it is very simple. Therefore, generally, this compound will be formed when 4 molecules of chlorine will be used. So we are going to have this one, tetrachloromethane. And how many hydrogen chloride molecules will be produced? We have 1, we have 2, we have 3, we have 4. So this is the overall reaction. So the first one, one chlorine atom will be replaced in this one, as you can see. The second one, we have 1 will be replaced to make this one to remain with 2 hydrogen atoms, as you can see. The third one, as you can see from here, hydrogen atom will be replaced and the chlorine atom will get to be 3, as you can see. Then the last one is to remove this one there. So it is very simple. Now, from there, I can show you something also which is very important for you. If you want to get more readings from this particular presentation, you can follow this one. Chemistry for Secondary Schools, Book 2, 1995 Thai. Chemistry for Secondary Schools, Form 4, Revised Edition, 2011, Oxford University Press, Tanzania Limited. So let me take this opportunity to thank you for watching this program. Hope to meet you in the next presentation. Bye.